welcome to the last talk for this BalCCon. I hope you enjoyed the whole event. And the last talk is a primer on using Golang to do better, fun things. And please greet Vyrus and enjoy the last talk for this year. Thank you.
Hello. Everybody had used Go before? Anybody know what Go is? A couple people? Oh, a lot of people. Cool. So what is Go? So Go is Google's programming language. Anybody who's ever used Google Cloud, the little console thing they give you to spin up containers, that thing's written in Go. And it was made by these guys. Some of these names probably look familiar. They're also the guys who wrote Plan 9. And pretty much everything about Go is kind of Plan 9-ish. They're very big on their programming philosophies. So Go is, to look at, it's kind of like this mix of Python and C, but it's very, very, very simple. The syntax is very clean. And it is a compiled language. It's static typed, and it compiles to almost everything, which we'll get to in a sec. So it works on everything. No, really, everything. And actually, as I was writing this slide, I found out today, actually, that not only do the Linux variants that it works on include Android, but apparently somebody also in the last week ported the Android shared object container to iOS. So now apparently it works on iPhones also. And it works on a lot of architectures. All the underlying stuff is written in C and assembly, and if you talk to the developers, the first thing they'll tell you is that their mission for the next year is actually to remove all the C. So hopefully by 2016, it'll be a language entirely written in assembly, and then all the other tools are written in itself. So that's always nice. So Go's got a lot of really cool, just general programming features that are nice for getting stuff done and not spending a lot of time dealing with language minutia. One of those things is compiler macros. So a compiler macro, like in C, usually you have your ifdef, BSD, or ifdef, whatever, and these giant make files and giant pain in the ass. In Go, you can do that with files. So if I have like my file underscore Windows and I name a function, and then I have another file named exactly the same, but it has underscore Darwin in it, and I have exactly the same function name the same thing, and then I go build my program, the compiler will intelligently use the right file and link the same way with the same code. And then anytime where there are function overlaps, it will intelligently not use that code. So it'll compile the same function for both versions of the program. Another cool thing about Go is it has these things called Go routines. So Go routines are threads. In Go, you don't need pthread, you don't need boost or any of that junk. Go has this kind of brain that sits at the top of it, of every Go process, called runtime. And there's no way currently, well, without doing things that you shouldn't, to compile Go without using Go runtime. And Go runtime gives you all these fun little features like garbage collection and some of the stuff we're going to talk about in a minute. And as a function of that, it is its own process. So every time you need an anonymous function to spin off and do its own thing, you call it like that. That's not pseudocode. That's literally, that works. You can compile this. And you can spin off threads and do stuff. So security. Right? So when you're deving stuff for security, usually there's two big pitfalls when it comes to finding bugs, right? Crypto and parsing. Well, all of Go's parsers are written by the guy who wrote UTF-8. So he can probably write a pretty decent parser. He has this whole story on how he supposedly invented UTF-8 on the napkin of a diner in New Jersey. And he thinks himself very important, kind of like Linus Torvald. And he wrote a couple of other important things, like the language. So the parsers in it are pretty good. It's pretty safe. There's been a couple of bugs, but for the most part, it's pretty memory safe. He's kind of really into himself. So yeah, it's really good at parsers, and because it's really good at parsers, there's a lot of library support for a lot of commercial protocols. This is a tiny sample of protocol parsers that already exist just by default in the language. There are thousands upon thousands of libraries out there that take all this stuff apart. There are analog parsers for serial wire interfaces. There's video stuff. There's audio stuff. There's protocols for controlling robots that can get parsed in independent marshalling. It's pretty ridiculous. So part of the reason why Go parsers are so useful is because the language has this trick that it can do called type switching. So Go is a statically typed language. So when I define a variable, I have to define that type. But Go also lets you define your own types, and those types can be composited. So there are functions under the hood that do things called marshalling. So this is an example of a JSON marshaller. If I want to turn a bunch of text into, or if I want to get text out of a JSON structure, and all I have it is as the string, that's not pseudocode. That's literally, that compiles. That's what it looks like. Yeah, I have an object. And I don't have to worry about overflows or garbage collection or any of that. If I want to take the same structure and I want to spit it out again, that's what it looks like. Again, not pseudocode. It's very simple. Go, since it's compiled, can link to other stuff. And one of the other stuffs that it can link to is C. So when you download Go and you install it, it comes with two compilers, the Go compiler and an interface to GCC. And they call it GCC Go. And GCC Go can include raw C in Go files. So if you have a .h file that does some awesome hacker thing and you decide you want to call it with socket code in Go, because making a socket in Go is literally one line of code. I'm going to show it to you in a minute. You just include your .h and call it exactly like that. Again, that compiles. That's actually the CGO style from the web page. So there's all kinds of fun little language features in there. It's got type assertions like we talked about. It's got its own version of the Python one-line web server, but it'll compile to every operating system under the sun, so it's a little more useful. It's all kinds of stuff. So now we're going to talk about hackery things, right? Because all the language stuff is great, but this is a HackerCon, not a DevCon. So this is how you load shellcode in Go. That's not pseudocode either. That works for real. And the awesome thing about this is that since everything you do in Go ends up under the Go runtime header, antivirus is really bad at finding it. And you don't have to do anything fancy like packing or something to do that. Also, since the threads that it creates are dynamic inside runtime, and since runtime is changing all the time as they update the language, they're kind of doing your obfuscation for you. So that's nice. So this is the same code on Linux. This isn't pseudocode, but there's a function missing where it says disable NX. Any of you who've written shellcode loaders on Linux know that I'm missing the full mprotect header, but it works the same way. You just, I can dynamically load a syscall. I can, tell that syscall I want new memory. I can push stuff into memory and then go, OK, execute it. Go won't argue. Daemons. So Go currently does not have a way to daemonize stuff, which is really annoying. And if you go into the channel or you go to any of the help documentation, all of them will tell you that daemonization is impossible. They are lying to you. You can. They just don't like the way that it works now. So this is a poor man's daemon that I've written for some of the tools I've had to write so far, because there's no easy daemon in Go. I guess I kind of got ahead of myself. So the reason there's no easy daemon in Go is because, so daemonization 101, right? You have a process, you fork that process, and then you fork again, And when you fork again, that's like the cheat code of telling the operating system that this child no longer has to be responsible for the two parents that precede it, and then it goes off and does its own thing. The problem is that when you fork inside a process, you can only fork in the current thread. And since you have Go runtime above you at all times, there is no such thing as a single-threaded Go program. So fork, by definition, doesn't work. But there are tons of ways around this, and all the ways around this are already implemented in a Go library called exec. And what exec does is call whatever your operating system's version of start new program is. So in Windows, it's start process, and Linux, I think it's like S process or something. FreeBSD has their own. Anyway, so you can call yourself with an argument in a new process and say, do new things, and it'll totally work. And actually, one of the examples I'm going to show you, if you do this with the one-line web server, not only does it work, but if you do it on OS X, the OS X kernel tries to help you when children processes without attached parents fail and restart them. So if anybody decides to play with this later and the one-line web server on a Mac, be careful, because I have created processes that I couldn't find to kill again and had to reboot my laptop. So that's the one-line web server. Again, not pseudocode. That is literally how you do it. And there is a fun trick you can do with this. There's so HTTP is obviously a library, and there's a bunch of stuff in there for making websites or making web servers and doing your own thing. And recently there's an update to it. There's a function in there called hijack. So if you decided you wanted to write like a web server that started spitting out binary video data because reasons, you totally can. You can dot hijack. If I were to take, I have an editor in front of me, but if I were to take this handler that this spits off and literally put dot hijack on the end of it, it'll give me a raw socket, and I can just pipe data to it. So that's kind of fun. Shells, and more shells. So there's this guy. This guy actually works for Veil. I don't know if any of you have ever worked with the Veil exploitation framework. It's useful for, pretty much every pen test in the world has used it to pack Interpreter when it's being annoying because antivirus. So Veil actually uses a lot of Go under the hood. I'm pretty sure they're not telling anybody that because they don't want people to start making signatures for Go binaries, but honestly, they mutate so much that it doesn't really matter. And that's his public GitHub, and he's written a lot of cool little shell emulators for Go. So that also is not pseudocode. That is a real example of a reverse shell entirely written in native Go that uses raw sockets and no other libraries. So that's nice. I've used that on jobs. So I wrote this. This is a PCAP handler in Go. That's the whole thing. Any of you ever written a sniffer before? Usually takes a lot more code than that. This is actually from a project that I was going to release, but it's a little too buggy for me to release right now. I'll probably have it up on the internet at some point. I'm using it to bypass host firewalls. So you run a PCAP listener on your implant, and if the operating system has a firewall that says no packets allowed, it doesn't matter because you're sniffing packets, and your packet sniffer goes, oh, that one's for me, and then does evil things. VNC. So at one point, I decided it would be really funny to be able to deploy shells that I could send silent commands to on clients. I'm a pen tester. That's what I do for a living. And have them send VNC shells back to me. That way I could have video of like what people are doing in real time. I thought this would be funny. And I thought it was going to be hard, right? I'm like, oh man, VNC, like, nobody messes with the VNC protocol. They all just use clients and run it as infrastructure. Turns out there's a ton of people who've been messing with VNC on Go. So this was the first thing I found when I went to go research it. This guy was like, oh, I just wrote this VNC push client. And the comment after was, oh, I just wrote a server library. Turns out a bunch of people wrote server libraries. So there's like 2 or 3 line little code snippets out there that will launch VNC servers, which is probably really dangerous, but sounds like fun. Also, apparently, DigitalOcean is a large cloud provider. I don't know if you've ever used their stuff. They just rewrote their whole management stack for their VNC solution in Go, which, I mean, there's only 3 libraries out there to do it. I'm sure they didn't write their own. So if you want to fuzz something, food for thought. Speaking of fuzzing, so this is a real live example of calling AFL on a chunk of Go code. This is cooler than it looks because Go does not allow dynamic loads, because the Plan 9 guys are very anti-dynamic load, and that's all I'll say about that because I don't want to start a fight with a bunch of language zealots. But being able to call a fuzzer on code before you compile it dynamically that doesn't allow dynamic loads is kind of cool. And that's literally how you run it, so that's nice. That library is public. So yeah, Go can be used for all kinds of stuff. And a lot of that stuff ends up in being rapid prototypes, and those rapid prototypes can very quickly scale up into production systems. And right now, it's almost entirely being used by startups and dev people and people doing very constructive free and open source type things. And none of these people are hackers. And I love those people to death, but those people yell at me very fiercely when I walk into their channel and go, how do I call, how do I change memory protection on code? Why are you doing that? Well, that doesn't answer my question. So, yeah, if you're bored and wanting to write implants and wanting to hack some things, it would be great to have a larger, shall we say, gray hat security community messing with the language. Every talk needs to have a demo, so I have one for you. It's not amazing, but I will show it to you. So if you go to my GitHub, which is Vyrus 001, I've got one project public, and it's called Polaroid. So Polaroid is, so like I said, I'm a pen tester. I break into things for a living. And as a person who does that, I have to do a lot of phishing. And anybody who's ever had to phish large corporate entities very often knows that the hardest part of doing it, aside from the infrastructure piece, which you can kind of automate, is cloning the site, which seems like it would be the simplest part. But honestly, just whether it's Salsa Engineering Toolkit or Perl RAM or any of those other site cloners, they just break. They always break on something. And I find this terribly annoying. So I wrote something in Go to clone sites for me. So we are going to clone GitHub, because why not? Oh, except I should probably put my computer on the internet to do that, huh? That is it allowing my firewall. So now, we're going to load up. So this is what github.com looks like. And if I go to localhost right now, it looks pretty the same. And so if I wanted to type some input, notice the input comes from the actual GitHub server. But we have this great log with all the tokens and the usernames and everything else. So, not amazing. There's other stuff online that does this, but the other stuff online that does this is somewhere around, 2,000 lines of code, right? I mean, set, I think, is the most packaged solution, and I think it's something like 10,000 lines. Yeah, this is about. It's about 200. And I wrote it in about an hour. So anyway, that's my pitch of why Go is cool. Come on. There we go. In conclusion, there are some bad things, because nothing's perfect. There's no daemonize, which is kind of a pain in the ass to get around, because the only way that I figured out how to do it without doing a lot of stuff that functionally breaks the language under the hood is the argument trick that I showed you, and that requires the binary to remain on the system, which is, we don't like that for malicious reasons. There's no dynamic linking, which there are actually lots of ways around, but you do, if you're, as a hacker, you're going to have to write a thing to do it for you a lot, because you're going to want to do it a lot to do malicious things, and it's not hard to write, but you have to write it, so I list it as a negative, because it's something that you don't have to do in most other languages. You must use Go runtime, and aside from all the reasons that I've cited about Go runtime being a positive, the reason using Go runtime can be a negative is because Go binaries are very, very big. The way that Go compiles runtime is that runtime loads a series of base functions, and then any library that you include, usually when you're working in C or something else that's compiled, the compiler will look at what you're calling out of your .h file, out of whatever you're linking against, and then only take what you need and compile those things linearly into your package. Go doesn't do that. Go will take the whole package and put the whole package in the binary, and then your program is actually just this little blob of links. So that means that there's not a lot of exploits in Go that have been public, but if you find one, it's trivially easy to write shellcode, because you just use the language. You just link to whatever function is there. I mean, there's no ASLR or anything like that. Everything's in the same place. And it compiles on every operating system, so it's in the same place all the time. And actually, that link is to somebody who found, this is the most recent security bug I'm aware of. And it was immediately patched, but Go binary sizes are annoying. Supposedly, this is something that's on the to fix list according to the devs, but them being development people and not security people, I'm pretty sure it's like priority 8 of 10. Anybody have any random questions about the way Go works under the hood? Anything? Weird memory stuff? Okay. Well, thank you for letting me bore you to death.